I will now introduce our speaker, which is Tony Belpaeme. Tony is a professor at Ghent University and a visiting professor of Cognitive Systems and Robotics at Plymouth University in the UK. And he received his PhD in computer science from the University of Brussels and currently leads a team studying cognitive robotics and human-robot interaction. Now I give the floor to Tony, and thanks him again for joining us today.
Well, thanks for having me. Let me just start by sharing my screen. There, I'll assume that you can see that.
Yes.
So thank you so much for inviting me. I only thought that young people did this talking robotics thing. So I was very surprised to receive an invitation. First of all, Happy New Year to you. May your glass be half full, lots of positive things this year, except medical tests. Given that you've invited someone who's slightly riper, I'm going to use the opportunity to look back at HRI and AI, not just 1 year, but I'm going to take a look way back to the middle of last century. So when we just started building machines that could calculate, we immediately, across various regions, started thinking about how we could make these machines intelligent. And this is just a first page from a paper by Alan Turing. But many different people started thinking about how to build machines that can think. And in the initial days, there was a huge amount of enthusiasm, but also a lot of hubris. So people were overly optimistic, and it all centered around this principle that AI, that human intelligence and human cognition, actually cognition is a better word, could be described in such a precise way that you could program an equivalent on a computer, and then if you feed it the right data, that computer, that machine would become human-like intelligent, so artificially intelligent. And there's this apocryphal story of Marvin Minsky asking a student to solve computer vision as a summer project. I don't know if that's true, but Minsky did say that within a generation, the problem of creating artificial intelligence will be substantially solved. Now, McCarthy and Minsky are both no longer with us, so we're certainly one generation on, and we haven't really got the AI that they thought we were going to have. Now, we do have amazing AI applications, I think. At the start in the 50s, we focused on very cerebral pursuits, so on board games, chess, checkers, backgammon, and thought that if we would crack that, if we would have machines that can play chess, then anything else, like having an interaction, would be easy. Now, it turns out, of course, that that isn't the case. By 1997, we had a computer beat Garry Kasparov, the then champion in chess. And with it, we had this huge kind of arsenal of AI algorithms that are now being used to basically power everything in computer science. And we don't even consider them AI algorithms anymore. Things like search and planning, we don't consider that to be AI really. It's just standard computer science now. But we haven't got the AI systems that we thought we were going to have. Instead, what happened was that AI kind of scattered, and I heard Ruth Aylett talk about hype cycles in one of the seminars, and so I thought, hey, I'll reflect back on that. So here's the Gartner hype cycle for AI. So they release one of these cycles every year, or one of these pictures every year, and you can see that AI kind of separates into 30 different efforts. It's not really important where they are on this hype cycle, but what I want to show here is that it has scattered into 30 and possibly even more different efforts to create AI. different aspects of AI, different algorithms, different applications, different ways of implementing algorithms. And it doesn't seem to come together. And I think that's a shame. The best AI paradigms, the best ideas that we had kind of unified things. It brought everyone together. It galvanized the research and the products that we were building with AI. And over time, we've had lots of different ways of looking at AI. We had symbolic reasoning, which was kind of, at the birth of AI, we thought that we could kind of get there. We could reach the pinnacle of AI using symbolic reasoning. Turned out that that wasn't the case. That was followed by expert systems in the 80s. And again, that got somewhat stuck midway the mountain. We had various waves of connectionism, so that's kind of connecting things together that work in parallel, such as neural networks. And we're living through, I think, the third wave now with deep neural networks. And again, they're always getting a bit higher, but they're not quite reaching the peak. We had artificial life, nouvelle AI, various other forms of deep learning, sequence-to-sequence networks such as transformers or deep reinforcement learning. Every time, some of them kind of get stuck in the valley and don't get anywhere. Some seem really promising and then get stuck on a ledge somewhere. And that peak, this is a picture of K2, by the way, that peak we don't seem to reach, and seems to be ever beyond our grasp. Now, what I find interesting is that we also had a number of these waves in robotics that were really promising. One of them was using biologically inspired robots. And so in the 80s, Valentino Breitenberg, an Italian neuroscientist and cybernetician, wrote a small book in which he did pen and paper exercises and built very simple systems that would exhibit complex behavior. And it really pleases me that the logo of Talking Robotics is one of these Breitenberg vehicles. And nobody built them in the mid-80s, but by the late 80s and early 90s, we had behavior-based robots. This is a picture of Genghis, one of the robots coming out of MIT. And these robots were fairly simple, but they would exhibit very complex and very robust behavior with very limited AI, actually no AI at all. They have almost no internal state, very simple control mechanisms. And Rodney Brooks very eloquently said that we could create intelligence without representation. And indeed, it kind of changed the way we view things. And it almost directly fed into human-robot interaction with Cynthia Brazil, then at that lab, kind of using those principles to build robots that are reactive, that are very responsive, but then in a social manner. Another paradigm shift was developmental robotics, where we looked at developmental processes in animals, and specifically in the human animal, to build a new kind of robot. So not being quite content with the progress in current AI, we thought that AI needed to move through a developmental process, that it needed to kind of explore the world and learn from interacting with the world, and that would kind of bring us to a new form of AI. It didn't quite. The kind of AI that we got was fairly limited. We had systems learning motor skills, we had systems developing perceptual skills, but it didn't really kind of bring the performance of AI to an unprecedented level. What it did do, and certainly in my group, was it taught us a lot about what human cognition really is. And sometimes we had collaborations with psychologists that were at that time just amazing to us. So we used this robot here, iCub, and you see Martin Penyak and Tony Morse in the picture there, who were really instrumental in this research. And what we did was we let this robot run through a developmental process. So, for example, to learn to use its hands or to learn the meaning of words. And what we discovered was that this particular robot always failed to lose the association between words that it had heard and the visual reference of words when it changed its pose. So when it moved its legs, it forgot what the meaning of words were, which was fairly odd. But we made a prediction and thought that the same thing would happen with children. So when children are learning novel words and they change pose, yeah, they go from standing to sitting or the other way around, they would lose the meaning of the word they just heard. They would forget what that word meant. And so Linda Smith at Indiana University in her baby lab then actually used our prediction, did the experiment, and saw that indeed that is the case, that changing pose makes you forget the word that you just learned, or makes you forget the meaning of the word that you just learned. And for us, it was absolutely fascinating that, hey, we were just engineers building robots, and suddenly we become meaningful to psychology, to developmental psychology. It was a very exciting moment for us. And so I think that the greatest paradigm shifts, or the greatest ways of thinking about AI and robotics, do two things. On the one hand, they give you a new way of solving problems in AI and robotics. And sometimes that really immediately leads to products as well, such as the Roomba vacuum cleaning robots. Yeah, there's about 100 million Roombas and Roomba ripoffs being sold now. And it can be traced back all the way to behavior-based robotics. And I think it's just fascinating to see that 20-year development from a crazy idea, someone kind of rallying against the establishment in AI, all the way to a product 20 years later. But next to that, a good AI paradigm also changes our understanding of intelligence and cognition. And the question is, would this be the case for human-robot interaction? Does HRI do this? Does it have this double contribution? And I think it does, yeah? And I'll just try and argue that right now. So in our research, where we use robots to teach children a second language, we were forced to ask some questions about how children actually learn another language. So for example, we had this idea that manipulating physical, real objects was very important to learning a second language, and that you would learn faster and more effective in that sense by holding things in your hands. And turns out that this wasn't the case at all. Once you have a concept already established in your head, learning another word for that concept doesn't require you to physically manipulate that object. Instead, you can just learn from seeing that thing on a screen. You don't need the 3D physical experience, which was great for us because it meant that we could get away by displaying content on a screen, and the child and the robot talking about what they saw on screen. We didn't need to have things presented physically for the young learners. So it kind of cut two ways. It helped us build better robots, or a better robot system, but it also helped us learn about how children actually learn, how children learn a second language, which I thought was really fascinating. So yes, HRI does have an impact beyond HRI. So HRI has been around for about 20 years, and it's fairly modest. If I look at my own research and I kind of look at who cites my papers, mainly it's people within the community. But there are some papers that actually just kind of break that boundary and get cited by different fields. And so the Scolarometer of Indiana University is a tool. It isn't amazing, but it's one tool that allows you to see with which fields your discipline has got contact. And of course, with HRI, that is cognitive psychology. So these people are benefiting most from what we're doing. And increasingly, in the last few years, we saw some explorations along that route. Robots are being used to as a research tool to actually do very rigorous studies in which you can control the social behavior with a robot and see how people respond to that, and not as an HRI tool, but really as a tool to answer questions that cognitive psychologists are interested in. But what about the AI? Is HRI actually driving AI as well? Well, it's a mixed message there. So if you look at our publications in the field, we see that still about half of publications rely on teleoperated robots. So half of the studies use Wizard of Oz. Now, there are good reasons to use Wizard of Oz. Sometimes you just can't do anything else. So imagine you have a robot that needs to interview a child about an abusive situation. You don't really want autonomy there. You want a therapist, or perhaps, I don't know, someone from law enforcement to interrogate the child through the medium of a robot. So you need teleoperation. But in 99% of the cases, of course, we use Wizard of Oz to, as a stub for underperforming technology, typically speech recognition, natural language interaction. We're going to be using someone who kind of sits in for that technology and controls the robot. But of course, we need to move away from that. We can't keep doing this. The dream is to build autonomous robots. But we all know that programming social behavior by hand is hard and very time consuming. And what we can do is always limited in scope. It's fairly narrow interactions. They're certainly not long-term. And the commercial efforts always tend to kind of not meet expectations. And I've put 3 pictures here of commercial robots that tried or that try, in the case of Astro, autonomous human-robot interaction, and all 3 are pioneers, and should be really commended for that. It's just amazing what the people behind Jibo and the people at Anki did. Astro, I haven't seen in real life, but I'm really keen to meet Astro, and it's amazing that these teams dare to build autonomous HRI, and I think it's an important effort, because HRI has got a number of things that other fields don't have, and for one, HRI is brain complete. So if you are engaging in a social interaction, your entire brain lights up like a Christmas tree. Everything is active. All cognitive faculties are engaged. Memory, motor cognition, language, visual perception, emotion, it's all there, it's all active. Perhaps the only exception would be some motor skills for example, I don't know, locomotion, or for manipulating physical objects that might be less active during a social interaction, or not at all. But for the rest, it's this challenge whereby the entire brain is doing something. So it's kind of a great goal to aspire to create autonomous human-robot interaction. Another reason is HRI, or social interaction, out of necessity, will teach you a lot about human cognition. Yeah? And many of the AI paradigms have focused on non-human cognition. Behavior-based robotics focused on animal-like cognition, didn't focus at all on human-like cognition. Developmental robotics often neglected the social aspect, and because HRI, you cannot escape, you can't take a shortcut, you have to engage with social cognition here. Now, there are some limitations, of course. Yeah? So it could be that we don't need human-like cognition to engage in HRI, just like you don't need to build flapping wings to build a plane. So you could be disappointed if you try to learn more about what social cognition is like in humans. Building artificial social cognition is not guaranteed to actually give you insight. And so that could, might be a problem. HRI is unlikely to solve all AI challenges. You're not going to be building a general problem solver. You're not going to be building a robot that manipulates the physical world through building HRI, and that's a limitation that we have to just agree to. Another problem, which I think is more interesting, is that robots and people meet halfway. Social interaction is a dance done by at least two parties. So you've got your robot, you've got your person, and the social interaction is something that is created between those two. And separating the two is almost impossible. So if you see a successful interaction, it might be difficult to separate what it is that is exactly going on there. Now, that is useful. Yeah? It's the reason why we can build HRI at all, because we have fairly limited robots with fairly limited autonomy, but still we can build robots that work in education, therapy, in entertainment. And it's because we project sociality onto those robots. But if we're trying to kind of understand what is going on, exactly what it is that makes this social interaction successful, it might be hard to do so because you can't separate the two. Now, another cool thing about HRI is that it allows us to answer the big questions. I should have capitalized big question there. A question like, what is intelligence? And how much is social cognition contributing to human intelligence? As Matthew Lieberman said, social cognition is our superpower. As a human species, if you compare what we do to our nearest ancestors, so the apes, you see that they're as good in physical cognition as us, but in social problems, they just fall behind. And we are this really unique this really unique animal species. We have this unique human social cognition, and it's just so fascinating. Recreating that in machines will help us answer why we are so unique. Other big questions, and I'm taking inspiration here from Dreyfus's book. So he initially wrote this in 1972 and then updated it twice every 10 years, and the last version dates from 1992. He said that computers will never understand, that they will never have true meaning, that the symbols they manipulate, the bits and quantum states, etc., that they manipulate will never have true meaning. But again, with human-robot interaction, we will have to tackle that problem. And I think just the grounding afforded by having embodied robots, by interacting in the social environment, will already add so much more meaning than what we used to have in those times. So HRI might be able to answer that question. Another really big one, and I used to trade around that for a long time, is consciousness. If you see consciousness just as information integration, attention focusing, reflecting on the self, and if you don't see consciousness as this kind of esoteric kind of, I don't know, thing that sometimes is almost considered unscientific to talk about. But if you just consider consciousness as being aware of what you're doing and aware of your consequences on the world, then suddenly consciousness really fits into HRI. Yeah? If you have an AI system that needs to be aware of the consequences, the values of its actions and its behavior, and of the values of what others are doing around it, then suddenly you have a system that becomes consciousness. And so HRI has something to say about consciousness. But how do we build this? Yeah? And of course, hey, that's the big question. I don't know. I don't have a good answer here. And so does HRI need a new artificial intelligence, or can we get away with being, with just taking bits and bobs from other AI efforts and integrating them? Can we just pick and mix from what exists now? And how far can data-driven methods get us? So if you look at the language models that we have now, BERT and GPT, it's amazing what you can do by just pumping lots of data into a model. It's not perfect, and it's fairly easy to just kick it down, but I'm fascinated by how much kind of seeming intelligence there is, how much semantics comes out of these models, and how far can this get us? And just to illustrate, I'll show you a little something that we've done in the lab in the last few months. We looked at building chatbots that become multimodal. And so this is work by Ruben Janssens. And if you think of a chatbot, you typically have a fairly, a unimodal interaction. You're typing text and then the chatbot comes back with a reply, which is again text. But on the robot, if a robot has eyes and ears, we want this robot to be able to see us. We want this robot to hear us. We want this robot to be multimodal. So just putting a chatbot on a robot won't work. And we asked ourselves, how far can we get by this taking data and taking existing systems to build a multimodal interaction? And to kind of make life a little easier, we took a problem of the problem of conversation starters. So every good conversation starts with a conversation starter. And typically that is some remark on a visual reference in the environment. Most often, the most effective conversation starters are about something that that you're wearing, something about your person. So the way we did this was we first collected data. So I'll talk you through this little flow chart here. So the dark blue bits is where we collect data. So we took photos of people facing the camera or looking into the camera, and we thought that these would be similar to situations that a robot might encounter. So someone walking up to a robot and looking the robot in the eye. And then we used crowdsourcing to gather conversation starters. Things like, have you always had freckles? Were you born with red hair? Is white your favorite color? Polite, short questions, which our crowd workers generated for us. Then the next thing we did was use a number of AI models. The first one that we needed was a captioning model. So this is a model to which you feed an image and it just generates descriptions. This is a dense captioning model, so it tries to describe as many things as possible in the image. So we give it this picture of this man, and the model comes back with a man with brown hair, the eyes are brown, the man has a beard, and so on. And then we use those captions and the data that we collected to train a question generating model. So this is a natural language generation model based on BERT. And when we try it on our robot, we get something like this. So the robot meets someone new, looks at them, and then comes up with a polite question. Where did you get those earrings? Here again, the salient thing seems to be the red top that this lady was wearing. Here the robot seems to find the glasses interesting. And even if you dress up, the robot seems to pick that up. So here it comments on the necklace. We've tried different models. They seem to work. They all have pros and cons. I haven't got the time to go into that. But what it kind of shows me is that I'm excited about this. I want to build this autonomous HRI, and I think we have been staying away from that for just too long. So I'm going to conclude by kind of, with a call to arms, really, to build autonomous human-robot interaction. We have been studying how people respond to robots for a very long time, and I think it's now time to build that dream. And so I hope that the next 10 years are going to be that moment where we can build those robots that are truly interactive in autonomous way. I'm at home at the moment. I've got tons of robots just around the corner. A Pepper and a Null and a Vector and a Roomba. And every time people visit, they go like, "Oh, cool, robots! Can they do anything?" And it pains me to say that. The Roomba is fairly good. You can switch it on and it does something autonomously, but all the other robots don't really. I can switch them on and they see blinking lights, but there is no one home, and I want to change that. And it really pains me. We've got a dog at home as well, and people are actually, after a few minutes, more interested in the dog than in the robots, and I want to change that. So let's hope we see that change in the next 10 years. And then there's one final thing I wanted to say to you, and that is HRI 2020 was due to happen in Japan, in Sapporo, and of course, due to COVID-19, the third time in a row, we had to cancel the physical meeting. So there's only a virtual HRI conference. But some people, including Cyril Lemagnon and myself, have decided to organize a European meetup. So anyone who's allowed to travel to Europe, we're going to come together for 2 days, the 9th and the 10th of March. That's a Wednesday and a Thursday in Barcelona. We're going to be having some real human-to-human interaction there. We'll be watching talks of the HRI conference, the keynotes, a selection of talks. We'll have poster sessions. There's going to be networking and all the things you do at a real conference. So more details at that URL. Check back. We're just kind of planning this thing, and things are still developing. So we will need to charge. For example, we don't yet know how much we're going to charge, but we do look forward to meeting lots of people who can travel to Barcelona there. And I'm going to finish here and listen to you. Thanks.
Thanks a lot, Tony. It was really great talk, really great, and looking forward for the HRI meetup. Do you have any questions? Is there any question from the audience? Please raise your hand. Okay, a lot of people are clapping their hands. That's why they are not rising. Yes, there is a question. Please, Dan, you can go ahead if you want.
Sure. Hey, Tony.
Hey, Dan.
Thanks for the talk. It's always wonderful to hear what you're working on. I sensed a theme that you sort of talk about HRI only in terms of social interaction.
I know. This should have come with a help. Yeah, it should have come with a warning. Yes.
Can you just tell me a bit about why you focus only on that? Or do you think the rest of HRI is not interesting? Or do you think there's always a social component?
See, you oh, wow. I stepped into that one. Yeah, no, it is true. To me, HRI is always about social interaction, and it shouldn't be. There's wonderful work on how we control robots, how we deal with robot swarms, how we interact with industrial machinery, etc. And although there is, of course, a social element there, the social aspect isn't the main focus there. It's quite often about, I don't know, about awareness or situational awareness. It's about cognitive load, etc. And that is equally fascinating research. And it's just something I don't do. And I sometimes forget to mention it, that I'm going to focus on an aspect of HRI and not talk about that. So thank you very much for mentioning that, because you're right. And I feel guilty of even the book we wrote with a number of people. I so hope we can ever do a second edition of that and then give proper attention to other aspects of HRI as well.
Yes, we have another question from Andrew, if you want.
Thank you, Tony. Great talk. I was pleased to see you elevate developmental robotics to the level of a whole, I don't know, wave or generation of AI that made my heart happy. But you did talk about it as though it's over. I'm wondering if you think it is done. I mean, I think your criticisms are fair. What does it need to have a second wave, as you know, as connectionism has, and what does it need to have a commercial impact, or I don't know, a triple impact perhaps? You know, perhaps setting our sights as high as the Roomba is a little ambitious, but I'm interested in your thoughts on that.
Oh God, it's a fascinating question. So I think developmental robotics has plateaued. There used to be a huge excitement at the same time with cognitive robotics, taking inspiration from cognitive sciences and building machines. And we thought it would deliver solutions to problems we had at the time, and I don't think it quite did. But I'm not saying that this is the end of it. I'm not entirely sure what is going to be needed to give it a kind of a second, a second outing, really, or to make it climb again. But if you look at the conferences in that area, the conferences have been shrinking, and you see that people have kind of, the excitement is gone, the novelty is gone. So everyone is kind of waiting for something new. Is it going to be data? I'm not sure. I would disagree to using to using data-driven approaches in developmental robotics, because it kind of goes against what we see in natural development. We don't need tons of data, and I think the main contribution of the developmental robotics is it might be just that. How can we learn using this really limited set of experiences with the physical and social world? What is it that is already present when animals are born? What is innate, and what processes are there that allow us to just ramp up our cognition in a matter of months or years with fairly limited data? That's the open question, and nobody seems to have the answer to that. But if let's hope that's a bright PhD student somewhere is suddenly going to come up with an idea that kind of just gets this field going again.
And do you think that technical advance is necessary for some kind of a commercial success?
I think it's fairly likely. It's yeah. In terms of commercial success, I can't think of any commercial success that really. Do you have any examples of commercial successes coming out of developmental robotics? I don't have any. And so, yes, I think that is going to. It'll need a breakthrough. It'll need something to get people interested again and flocking back to developmental robotics. And I think this learning with sparse data might be just a trick.
Thank you.
Thanks a lot for the answer. There is a discussion going on also in the chat, and I mean, I also have comments, but I think we have also some space in Slack. I'll keep my comments for later, and would like if Philippa wants to add something about what is non-social HRI and the comments that Ross made in the chat, you can add them also loud if you want. Otherwise, we have also 2 other questions from Jennifer and Suraj. Please go ahead, Jennifer, if you want.
Actually,
yes.
maybe we can talk a little bit of what's going on in the chat, because I think this is interesting. Going on, what is social interaction between humans and robots? Because there's this question about there's no social HRI. I believe there is no social HRI. Like, for example, I gave the example of exoskeleton. You have human-robot interaction, okay, and you can study it, but there's no social interaction. Is physical interaction, there's no social signals involved in that interaction, right? So social, when we talk about social robotics and social HRI, we're talking about the communication has some social signals going on. Of course, humans are social anyway. And if they use voice, they use gaze, if they use their body language and so on, there's social interaction there. But I think the example of the exoskeleton is an example of you can study HRI, but not social, right? So Tony, back to you.
I'm trying to disagree with you.
Ah,
and
good.
I can't.
Good.
But actually, I think it's almost always, if a human is going to be in the loop, you can't escape introducing a social element, because we are a social species.
Yeah, but
and so you're okay. I'm going to try and disagree. No, even though I think you're right, but I'm going to try and disagree. I think everything that we do is rooted in a social experience that we had. Even simple things like walking. I wonder if we would walk without seeing others walk, and without having this urge to imitate what others are doing. So even walking might be a social, a social endeavor. Even though once you've learned to walk, you don't need to see others walking anymore. But the and I think even the exoskeleton that you fit, there's going to be trust, and trust is again, it's got a social element. There's going to be how people perceive you in your exoskeleton, which is a social element, and it's almost impossible to separate anything from social cognition. And I would agree that there's a large spectrum. There are kind of interactions that are kind of only and purely social, and using an exoskeleton to walk, of course, there's a large physical element of that as well, and the social element might be smaller, but you can't get rid of it. So perhaps any interaction we have with a machine is going to be, because it's an interaction with us, it's going to be social to some extent.
Yeah, but the interaction between the human and the robot is not social.
Now, you might be right.
I can give you another even more futuristic example. Imagine you have a robot that you put inside your body, and you can study your body, the interaction between your body and the robot. Where's the social aspect there? Okay. So there is a human-robot interaction that has the social.
So imagine we have a nanobot. But no, I don't know if this then fits in the field of HRI. This, if I inject a nanobot and it is doing something in my body.
Okay, but I'm taking it to the extreme. Yeah.
No. Point taken.
So
I agree. The robot is definitely interacting with your body when it's inside your body. It's a pacemaker, human-robot interaction.
All right. Okay. Sorry.
I think this is super interesting, and it's very good question also. Thanks, Anna, for pointing this out. I would like to take all the others, and we have very little time, so I hope we have enough. Otherwise, we put our Slack link on chat. Please, Tony, if you want to take other questions.
I'm going to do that,
yeah. So please, Jennifer, go ahead.
Hi. Hello, can you hear me?
Yes, we can.
Yes, thank you very much. It was a very interesting presentation. My question is related, I'm going back to the social part of it, actually. And I was wondering, I seem to see that most work done in social interactions with humans are trying to have robots imitating humans as much as possible, whether it is in visual cues, in natural language processing, and so on. And so my question is, we have interactions with non-humans, with our animals, whether they are called social interaction or not, I'm not sure, I'm not an expert, but I would call them social interactions, right? So would it be possible Or do you think that human-like features are absolutely necessary for successful social interactions with robots? Or could we have robots non-exhibiting human features and still be socially interacting with them?
Yeah, I think definitely you don't need the robot to be human. As you said, we interact socially with other things as well, other species, you know, dogs and cats and all kinds of other animals. And they don't look anything like humans. They don't have language, so you don't need that. But of course, for me, the ultimate dream is, of course, to kind of replicate human social interaction, and I think language is a very important element of that. So, understanding what language is and recreating natural language, or natural language interactions, I hope to see that before before I leave this world. But I'm not sure.
If I may, a quick
problem. Yeah.
If I may, a quick follow-up question: are we, in that case, aren't we limiting ourselves if we absolutely try to do human-like kind of interaction? Couldn't we discover maybe new type of interactions with robots that do not depend on human-like features? I
agree, absolutely.
That would be amazing.
Yeah, I'm so, and there's some people present here who do great work on building robots that don't look human-like at all. So Patricia's robot that she co-designed with kids, it's this little, I don't know, pot on wheels with fiberglass coming out of it, lighting up, and it's unlike anything you've ever seen before, and still we have a social interaction with it. So yes, there's some great work there, and you don't need a robot to be human-like at all.
I'll check these robots. I don't know about those. I'm interested. Thank you very much.
We will take one last question, and then all the others I invite really to continue the conversation on Slack. So please, Suraj, go ahead. You can ask your question.
Nice to see you again, Tony. And also wonderful talk. And I'm really happy to see your enthusiasm in showing a new direction to the HRI field. So I have a question regarding how HRI can expand to more people or in different ways. So what do you think is halting robots from going into the wild, like outside the universities or outside the laboratories, and reaching out to more people, such as like maybe communities in the developing world, so that we can get to know what is actually holding us away from having a successful social robot as per se?
Yeah, I think it's just robots underperform. It's as simple as that. We have certain expectations of robots, and these expectations are, culturally set or set through the stories that we tell each other, movies that we see. And when we then get access to a robot that doesn't meet those expectations, we are disappointed. And I think if you would create a robot that manages to sidestep those issues, if you kind of create something so new that people have no expectations about it, then you stand the chance of actually building a successful robot with the technology that we have now. If you can't do that, then the technology at the moment, the AI isn't ready yet. You can't do it. So it needs something really radical. What that is, I don't know. But I think a radical new robot, perhaps something, an animal species or a robot species we have never seen before, but that taps into a need for social interaction, that could be really successful. And of course, then you've got all the additional problems of commercializing something and then rolling things out in large numbers, so you can have lower prices, etc. I won't go into that, but yeah, build something that doesn't disappoint, and that's the big challenge.
Yep. Thanks.
Great question, by the way.
Ross, did you want to add something on this, or we can continue otherwise really on Slack if there are other questions also from Emma and.
Yeah, I can add really quick. I'm trying to answer the Slack and go here. So Tony, you got all these super cool robots in your home. Let's project out. We solved AI. Okay, we solved it. All this cool stuff you're talking about, we just solved it. It's done. What are those robots doing? You want to make them be cooler than your pets. What are those robots doing?
That's a cool idea. It helped me sort out my life, really. The stuff I forget. I hope they're going to be somewhere between a maid and a companion to me. That's kind of perhaps a friend. Humor would be important to me as well. Knowing when not to be there as well. Kind of just take a back seat when I don't want them around. I don't know. An ideal almost inhuman human, really. That's what I would want.
Okay, great. I think I will share again the link to join our Slack channel. And so here is the link. Please join. We have a specific channel section for Tony, which with his name, and there are some people who already started asking questions and participating to the discussion, so we can continue there. And I will now share my screen to introduce the next speaker.
Let me just stop sharing my screen then.
And so and really thanks, because the discussion was amazing. It's great when we have such a good discussion after the session. So our next session will be in 2 weeks from now, and we will host Demosthenis Kontogeorgios from Potsdam University in Germany. And he will speak about mutual understanding in situated interactions with conversational user interfaces. And so, yeah, I hope to see you all there. I think this also relates with what we have said today. So I hope to see you all there. We would like also to thank once again our sponsor, Animathas and Samuel, for supporting us. We are volunteering, and we could not do what we are doing without their support. If you want, also you can support us by buying us a coffee. We have our website there, and you can support us by buying us a coffee. Thanks a lot. Stop share, and yes, see you all on Slack for continuing this discussion. And thanks really, Tony, for joining us today.
It was an absolute pleasure. Thanks for being here all.